Hey, welcome back to the course. And in the previous lecture, we actually explored about the one of the most important peripheral of the microcontroller, that is GPIO. And from this section onwards, we are going to explore about the SPI peripheral. First, let's start with introduction. So, what exactly is SPI? SPI stands for Serial Peripheral Interface. So this is one of the protocol which is used to communicate with one master and a couple of slave devices in embedded world. For example, let's say there is one master device and there is one slave device. Slave may be anything. It can be your sensor, it can be W from chip, it can be SD card, it can be display or wireless connectivity chips such as Wi-Fi or Bluetooth. And if the master device wants to communicate with the slave, so the communication means if it wants to send some data to the slave or if it wants to retrieve some data from the slave, a specific protocol is defined, and SPI protocol is one among them. So there are various other protocols like CAN protocol, I2C protocol, Ethernet, USB, RS-232, RS-485. So there are various protocols and SPI is one among them. And the SPI bus, which is actually the collection of couple of pins. So about these pins we are going to learn in a moment, don't worry. Basically what you are seeing here is SPI bus or SPI bus, which allows the communication between one master device and one or more slave devices. So you can connect more slaves to the master, no problem. And how this protocol works and what are the significance of these pins we can study as we make a progress in this course. So, but you have to remember that the SPI is a protocol which is used for serial data communication between one master and couple of slave devices in embedded world. Let's move forward. So let's learn about these pins which are part of the SPI bus. The four I/O pins are dedicated to SPI communication with external devices. So typically SPI uses four or more pins. So the MISO pin, so where it is written as MISO, the MISO pin, which stands for Master In Slave Out Data. So basically MISO is data pin, all right? So in the general case, this pin is used to transmit data in slave mode and receive data in master mode. So as the name suggests, whenever slave sends data, so that data will be received over the MISO pin by the master. So the MISO pin is actually used to send data from the slave side and it will be received by the master. Now the next pin is MOSI. So MOSI stands for Master Out Slave In Data. So in the general case, this pin is used to transmit data in master mode and receive data in slave mode. So whenever master wants to send some data to the slave, it actually sends it over the MOSI pin. And slave receives its data over its own MOSI pin. So it's like you have to connect MOSI pin of master to the MOSI pin of slave, and you have to connect MISO pin of master to the MISO pin of slave. So these two are actually, they are data pins. So because they carry data. And there is one more important pin, which is actually the SCK or SCLK. So that stands for serial clock. The master, whenever it wants to communicate with slave, all the data which are there on the MISO or MOSI pin will be synchronized with the clock produced by the master on this line. So this pin actually carries the clock, the data communication clock. So all the data communication between master and slave is synchronized with the serial clock which is produced by the master. So hence SPI is also called as synchronous serial communication protocol. Alright. And remember that in SPI protocol, master is the one which produces the clock. The slave will only receive the clock. So the slave has no control over the serial clock which is produced by the master. So without this clock, the SPI communication is not at all possible. Alright. So that's why when the communication is not working, the very first debug tip is to see whether the master is indeed producing the clock or not. So when we make a progress in these lecture series, you'll understand more about these things practically. And if it is confusing to you, then don't worry. So you are going to understand more. And remember that there is one more pin that is called as NSS or SS, which stands for slave select. So let's understand about the slave select pin. So depending on the SPI and the slave select settings, this pin can be used to select an individual slave device for communication. So strictly speaking, when you have one master and one slave, then this slave select is actually not required. So this slave select makes sense only when master is communicating with different slaves. So master can select the slave to which the master wants to communicate. To make that selection, this pin is dedicated. So that's why it is called as slave control or slave select. Basically, the SPI bus is collection of these four important pins. And remember that these two are actually data communication pins. This is a slave control pin. So this doesn't carry any data, remember. And this is the serial clock which is produced by the master to synchronize the data communication between master and slave. All right, so that's a brief introduction to the SPI pins, and we'll understand more about the protocol as we make a progress.